provide information about who I am now. You know, these are exciting times, but I would like to think other people that lived in previous eras probably thought these were exciting times as well. You can use the next one. So it's quite a bit that is going on around us, right? Especially as it relates to data science, right? So think about this whole notion of data science from the perspective of perspective of knowledge discovery as it relates to different sort of data that is being generated around. Right? I always like using ZRA as an example because they've actually been mining massive amounts of data, right? I think we've had I've had the rare opportunity actually to be a part of people that have trained people from ZRA, some business unit at ZRA or something in Python and SQL and all those things. So I always find it interesting when we are looking at the sort of data that they are handling. But also, in addition, if you take time to go to the quote-unquote user repository, I'll probably talk about this, I guess, at some point. I don't know, the user repository or something. But if you go to the user repository, right, which is, I hope people online listening to us or something, and you kind of navigate to the collection, the community rather, that is used to make available thesis and dissertations. So outputs that are generated by people such as yourselves, people that are enrolled in advanced degrees at the UNZA, you discover that there are interesting studies that people that are pursuing the department have done, right? Quite a number from ZRA as well. So if you go to displace.unza.zm at your own time, you can navigate to School of Natural Sciences. Unfortunately, right, this is quite sad, if you drill into natural sciences, they don't need organizers by department. So you have to look at the titles, not a lot, 419, but also you can search, right, for some of these things or something like that. So quite a number of interesting things here. But there's quite a bit happening here, right? So ZRA here, I don't know, I can see someone who's from ZRA. I don't know if we're still playing around with some of these things. At the time when they say that ZRA had deployed drones or something, I don't know how that went, right? So I don't know. But this is interesting, isn't it? It's interesting because if you see how most of these entities currently would want to mine information and they have to take fraud, you notice that they use traditional approaches or something like that. But besides that, I mean, if you look at certain specific examples that we can easily relate to, like I know when this was shared, was it last year, there was Transparency International Zambia essentially went to the Auditor General's report and CDF and they summarized that information. It's a detailed report, right? I have no idea how the summary was done here, but hopefully one of the things that we get out of this course is and gain skills on how exactly to automatically do some of these things, right? So this is the report I was talking about here. Quite a detailed report, you can see from the size here. It would be nice really for the course project if maybe we can cover out problems that can force us to go and mine this information and try and generate knowledge or something like that. I don't know, or something. Yeah. So in essence, I mean, I'm just trying to give us an idea of what is possible, I guess, in programming for data science. I think it's fun. I think it would be fun. I don't know how many of us have experience with programming or something. I know I have, I must say this, right? They taught me how to program in 2000 and I was here between 2003 and 2007 when I graduated. And my introduction to programming was in secondary, which is 2004, so it's a long time ago here, right? And since then, I mean, I've worked in roles where I've been really done really mainstream programming. I spent some 4 years after I graduated here. I was working at Airtel, so there wasn't really a lot of intense programming, but scripting. So we're doing a lot of SQL, right? Creating SQL scripts and generating reports for then sales and marketing. And back then, I don't know if Airtel still does this, but we've actually, when you are launching those marketing campaigns, you say, can you extract usage patterns based on this band so that we have targeted targeted email, is it SMS or something like that? But anyway, so one organizes like so, right? Snacking some of the things that I've traditionally included in some of these postgraduate courses that I've taught, in part because at this level of study, there's certain things that we need to be familiar with. So I'll start off with Administrivia. It's a small group. I think we can, for now, we can do some personal introduction. So like I said, right, you find details about me on our research group website. So if you go to datalab.unza.zm, you will find a whole lot of information about me, right? So I have the profile there. And I think I don't know what I have on the profile, I should probably refresh it here, but it turns out that I'm a founding member of the Datalab research group at UNZA. I decided to set it in informal grouping. I decided to set it up, I think, a year into my stay at UNZA. I joined UNZA in 2017, end of 2017. So in 2018, I think, is when we actually set up this group. So you can find details about some projects that we do, and more importantly, I think for me, is the people that have been affiliated, the people that are affiliated or have been affiliated with our research group. Typically in an environment, an academic environment like the UNZA, it's expected to do some of these activities, right? Research is key. So it turns out that somebody like me is employed to do 4 key things. So it's not just teaching. So I guess you understand that it's very and also consultancy. So when I was at Kapasanakas, that's classic community engagement. And so you find details about my profile right there. But so that's that, right? And it turns out that I don't know if it's necessary for me to provide a bit of background here, but before I joined the UNZA, prior to 2017, I spent a very long time in graduate school. So I was at the University of Cape Town, beginning in 2011. So 2011 all up to 2013, I was doing a master's, and then 2014 to 2017, I was doing a PhD, right? And then before that, I was looking for Airtel, and then before that, I was at UNZA something. So that's that. I'm going to talk about this later on here, but I'll jump, and then it's a small group. Maybe we can go row by row or something. We can start personal introductions, right?
For sure. My name is Obi Kalenga. You can just call me Obi. My formal education background is I studied actuarial science here at the UNZA, and okay, I am working as a data analyst at Zamtel. And what I hope to get from the program is, I guess, competencies and skill sets relevant for a data scientist.
Zamtel, which unit do you work in? What sort of things do you analyze CDR reports and those?
Yes, I'm in the MIS department.
Okay, I used to be in MIS. Because I ran business intelligence and all that, so we do a lot of. It was fun at some point, the fresh graduate and the money was also good. But I think I got tired of just running SQL statements. The things have changed. You use sophisticated with data science and then these interesting things.
In terms of data science,
what tools do you use?
The tools that we use reporting tools like Power BI. Of course, Microsoft SQL Server for the scripting, use Oracle as well for the scripting, Visual Code for automations, ETL pipelines.
Visual Studio Code?
Yes.
Okay.
Yeah. It's pretty much the bulk of what we use in the around.
There is no companies with a lot of money here. They don't care about licensing. Oracle is expensive. I remember licensing fees you pay when I was with Airtel here, insane. But when you're making money, if you're a telco company, obviously you're making a lot of money. That's fine. So what? Oh, you've already told us. I guess you're trying to beef up those skills, which is nice. I think we can go there then. How do we stand? There. Yeah.
My name is Sarah Longwani. I have a bachelor's degree in mathematics, which I obtained from University. I'm currently working as a BI specialist at Zambia.
Oh, okay. Wonderful. 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 And what are you hoping to get from 6741? You do a lot of Python programming or something? You do a lot of that? Apparently, you guys, the things that are covering here, it's a lot of Python this, Python that, but you write a lot of SQL queries.
Yes.
Okay. You know, when I was my first week, I think then it wasn't actually impacted. It was Celta. I didn't remember Celta. My first introduction, I was shocked actually. One of the databases we were extracting data from was not normalized. Like, you know how it's supposed to normalize up to take normal form and all that. You know, but you know, this was a company that had a lot of money, so you just throw money at the problem, easily. Buy sophisticated set infrastructure at the time, right? This is 2000 and January 2007. You have a machine that had what 60 something GB of RAM, right? But you know, you sit down there, but if you look at what we have right now, you know, we can buy machines that have was 40 GB of RAM, but back then 60 something GB of RAM was like heaven or something. But anyway, that's neither here nor there. Thank you very much. Yes, we can.
My name is Foster Chirwa.
Yep.
I have a bachelor's degree in Bachelor of Science in Computer Science from Copperfield University.
Yes.
Currently, I'm a revenue assurance and product management specialist at Zambia.
Okay. Something is representing, which is good. Yeah. Okay.
So I hope to expand my knowledge in. I want to understand my field more. So that's why I'm just doing
Yeah.
last presentation.
You know, your mention of revenue assurance reminds me of I used to dread interconnect reconciliations with our revenue assurance team, right? You sit there and every month, right? You look at the CGRs matching from MTA and Airtel. It was quite nice. In hindsight, I think it was. At the time, I was more excited about take things here, and our revenue assurance team back then was not as evolved as I think right now. They're employing people with technical background, but back then it was mostly people that did not even know how to write SQL queries, right?
Yeah.
SQL people like Shishi. Okay. Yes, it's Zambia. That's okay.
My name is James Pandas.
Yeah.
I did Bachelor of Science in Computer Science, probably. And then I'm currently working at the Zambia as a business analyst. Yeah. What I hope to get from this course is more on the pipelines and just creating reports from that one.
Right.
I know much from the other side, but not much more into the pipeline.
Yeah, quite a powerful language, and it's actually a lot easier to learn how to program using the language. And I know this because I have first-hand experience. I have taught in the programming courses, but also my experiences learning how to program in Java are horrific. So you will probably like Python, I think. Quite very powerful actually. Especially when you start interacting with packages like Pandas, for instance. You know, I remember my interactions with people from marketing as well. They used to love Microsoft Excel, but when you're extracting millions, I don't know how involved Microsoft Excel has become now, but you find Excel is freezing, right? You know, or there's a limit in terms of the number of records or something. You notice that Pandas is different. So look at, I think we're going to have fun in the next coming weeks, I think. All right. Yes.
My name is John Monene. I have a bachelor's degree in mathematics from the University of Zambia. Currently, I'm tutoring from mathematics department. Why I enrolled for this course, I'm so curious to learn how I can incorporate the technology tools to make data-driven decisions in businesses and in other fields.
Yeah. You know, I mean, apparently computer science or these computing fields trace their roots from maths. You know, I may sit in some of these sessions, but looking at the program document, and I've noticed some mainstream statistics courses. I think people like you probably find it a lot easier to grasp those concepts, right? I think, you know, yeah, but maths is everywhere. I teach a computer graphics course, and I'm talking about translations here. It's all mathematics. Okay, we can wind it now.
I'm Denon Kreko. I did my bachelor's degree at the University of Zambia in mathematics and statistics, and then a postgraduate diploma in actuarial science. Yes. I'm a teacher in mathematics in Central Province, one district.
Oh, okay.
Yes. My interest in data started just after my undergraduate. When I started working, I found that in schools, teachers were too manual in handling the data. For example, when the results are announced, yes, they used to do it manually. Even request for biscuits, then they sit, do manual work. So that's where my interest started in. So I started with a bit of Excel, just trying to do situation, SPSS, then slowly moved to Python, Pandas, Streamline. Yeah, so at the moment,
You didn't build web applications, you should
not yet, still in the process of learning.
You know, a mention of analyzing data in the education sector reminds me of something, like a project we initiated a while back, right? I think it was interesting. And part of the reason we initiated this project is was low cost, you know. So I worked with some fourth-year students here when they're working on their capstone projects, and you know, we noticed something problem in terms of I have a whole bunch of examples. I wish I could. I think I can. I don't know. But we noticed a problem. I was teaching a computer systems and architecture course, and the failure rate was really, really high, right? And so what we did in this project is, so here's the thing, right? What we did was, we simply put, we actually built classification models. Right? We're interested in classifying. So if you have a cohort of students come through this year, first year, taking computer systems and architecture, our goal was to reduce the failure rate. So how do you reduce the failure rate? Well, it's like we will build a model that will tell us before these students fail that these students are actually more likely to fail, right? And so it turns out, and the reason I'm doing this is it turns out that we were actually mining information, a whole bunch of information actually, right? Why is this not more options? We were mining information from a whole bunch of places. So the learning management system, right? And this is a lot of information. If you look at indicator, if you look at the richness of information that you can mine from the learning management system, you'll be amazed here. So I don't know if it's 557 something. You'll be amazed, right? So what I mean is this: if you go here, if you go here, if I were to check a random course I teach, for instance, right, with a lot of like students or something, it turns out that one of the things that I would have access to would be the logs, right? So one of the things we're doing is we're actually interested in this sort of information. And really, based on the studies that we got, we realized that there were certain markers, okay, or features that they are called, that would tell us whether or not that particular marker would actually help us identify the students that were more likely to fail. So it's like engagement was one of them, right? To what extent are students engaged? Now, we can measure engagement in so many different ways. But what we realized, because for you to build these inference models, what you obviously need is data, right? It's like for engagement, how do you identify how students engage? So we're looking at these logs. This is a rich data set here. If you notice here, this is just for, this is when? This is on the 16th, which is today, right? So there's a record for this student here, Gooba, right? And they're doing a whole bunch of things here, they're actions. So you get this information for the entire academic year, right? And simplifying things here because the other markers we're looking at, is it? But you harvest this information, and before harvesting, actually, I wanted to showcase is a work in progress paper. It's been work in progress for a very long time. I want to showcase some nice graphs that we have that showcase a lot of interesting things here. But the idea was you get this marker, right? And you say, can we get similar information for last year? In fact, from 2018 to last year. Then using that historical data, when we harvest it, we train this inference model to say, when you look at a student who uses Moodle often or something, then they're more likely to pass or something. They're more likely to fail. But you generally don't use one feature, right? We use a combination of features. And in fact, what we did besides engagement is we were looking at the weight load of the student. You know, the more courses you have, the higher the odds that you perform poorly, if you will. You know, so it turns out the combination of those features ultimately led us down the path where we were able to implement a really nice, an effective model. I guess I can't remember the accuracy, but it was in the 80s. I think it was. SIG. I think it should be somewhere here. I don't know if there's a PDF document that I can download from here or something. Maybe not. I don't know. That's why. Be PDF. Yes. You know, so which was quite interesting. But we're harvesting, collecting data, right, and doing all sorts of analysis and all that. Welcome. Anyways, I don't know if this is complete here, but if you scroll down, you find a number of interesting. I don't know what's happening here, but a number of interesting graphs that we have. You know, things like these, and incidentally, what is this? Is this a graph, a chart, a plot, or something? Don't know. But these things were created using Matplotlib, some of them using Seaborn, which are some of the packages we're supposed to look at in this course, really. Anyways, and then we're doing fancy things like trying to identify which sort of estimator would be appropriate, is it? To try and give us a better result, if you will. But anyway, so we did a lot of interesting things here, like k-means clustering and all those nice things. But anyways, yes, I guess we can continue, I suppose. You found us introducing ourselves. Yeah, we're just following this script here, the full names whether you prefer to be called Mr. X, Mr. X, Mr. X. Dr. X, I prefer Lighton, we are colleagues at this stage.
My name is Aiden Ango. You can call me Aiden. For background, mathematics and statistics.
From right here, inside. The arm is here. You don't have to stand there. You can talk or sit there. You don't have to stand. Yeah. But and what are you trying to be busy with? Okay. Where is that? You collect what? Is it surveys or interviews or combination? Okay. I hope you are not. Are you the ones who did that poll? They're saying if election, that was December 25th, they said, if elections that will be held today, the incumbent will get 60% of the votes from them. That's data collected. Is it that close? Data collection. I don't know how they do this poll, right? Usually the methodology is kind of that. I don't know if it's a mass collection of data from all across Zambia. You just go on Facebook, right? Yeah, okay. And so, how long are you been with Pandas? Okay, that's wonderful. Do you focus on what sort of studies exactly? Is this? You're contracted usually, right?
Yeah.
Okay.
You have a lot of.
No, but
Yeah.
well, I do research, so yes, it's, but when, I mean, people like who start doing this content, obviously, you know how to do research. Okay, that's, and tools that you use to collect data.
Sorry.
Do you use Collector? Yeah.
There's also review.
A project that is a colleague of mine is consulting work with JCTR, and one of the things we did was we built we actually built a repository. I don't know if it's online. There's a repository and there's a digital asset management system, and I got to discover that they actually do use Kobo Collect as well, or they were planning to start using Kobo Collect to collect data about I don't know if people follow through it. But the cost of living in Lusaka now is 11,000 for a family of 5, right? And you hear all sorts of comments. It's always a certain tabloids here. Right? JCTR claims. But they tell you the methodology, right? We went to Soweto market, we went to this market, and then we compared the prices. This is how we arrived at these prices. Incidentally, it's no longer a BNB, is it? It's no longer a basic needs basket, it's a basic needs and nutrition basket. And people joke at the fact that, oh, they're including apples. Well, there's nutrition component or something. Now, yeah, so it's interesting, and those people collect quite a lot of data, right? By the way, I don't know if people know this, but if you go to the repository of JCTR.org.zm, you will find BNNB values for major towns in Zambia dating back to 2000 or something. So I'm working with a student. She's doing a master's in computer science, Miss Annette. She's a bit elusive here, but Miss Annette was at some point working for JCTR. So her interest is where is Annette here? Miss Annette. Her interest is to try and because the way JCTR works is they analyze this information, they collect this information using, I know it's Kobo or something. You hire people to go and collect data collectors, right? They manually go to markets. It's like Saturday market in Chipata, Kapata market, and all that, and then they average these results or something. But you see, what they do is it's a retrospective analysis, is it? This month they reported on the BNNB for January. So if you think about it, it is useful. Right? It helps drive policy direction, but not overly useful, right? Somebody like me, I would want to know how much money I'm going to be spending 2 months into the future, or 3 months into the future. So what Ms. Mnenge is trying to do here is to build models, right, that will be able to predict BNNB value using historical data. And it turns out it's not as hard as it sounds, really. And in fact, I think there's a small little component in this course where we get to look at specific types of estimators, right? And we'll be using scikit-learn actually, which is Python package for doing that. So already by the time I get into somewhere around April, if you're interested in this sort of space, you should be in a position where you can actually write this sort of models or something. And you know, the application, there's something interesting about some of these new technologies, right? There are entities that will not know the power of the things that they're going to be learning. So you have to literally go there and you're telling them this is what is possible. They don't know, right? They don't know that it can do something, but you know, that's okay. It's neither here nor there. Yes. Gotcha.
I'm Henry Smugalu. I studied physics here at the University of Zambia. I'm currently working for Zambia Regional Authority.
Is that right?
I'm a customs officer.
Okay.
So, what I expect to get from here, that I should be able to use this knowledge in risk profiling,
Right.
so that we can predict the compliance behavior of importers.
Yes. What sort of, I'm curious, what sort of things, is there an example aspect you look at to try and judge whether, you know, this entity is at high risk or something in terms of compliance? That's an example. Or what sort of data do you normally work with?
Well,
Or is it high charge? Maybe it's a trade.
no.
All right.
We look at which clearing agents they use.
Yeah.
We also look at the routes that they use.
Right.
For example, if you check the transport documents and then you see that maybe a consignment was moved instead of coming from, it's maybe straight from China,
Yes.
it seems to have passed through Colombia.
Right.
This way,
It's high risk.
then you think that there could be some illicit drugs in it and so on.
Yeah. And you know, ZRA is one of those entities that have rich data sets, right? Maybe some of them are going, like there's this, you probably don't do this, but we've been pushing for, what do you call this? I've forgotten the term you use. You've been aggressively pushing for business owners to adopt, I don't want to point to technology or something. You know how when you have the receipt, I keep receipts, I scan them, they're all, but you have a barcode and stuff. I've noticed there's actually a system where you can actually look up that information. You have a digital copy of that receipt, right? I've forgotten what you call it, but you've been pushing for that. Apparently, even businesses are going to be, I think it's the registered or something if they're not compliant. Smart invoicing, yes. Yeah. So you collect really rich data sets, right? Like when I was driving from Kinsali here, you stop and you see customs officers, I don't know what they're writing, but they're focusing on long vehicles. It's interesting stuff there. I don't know, you know, sometimes I sit and I wonder, what do we do with this data? Do we even analyze this data? Probably not, right? You're passing through a toll plaza or a toll station, and you know, they're capturing information about you. It's usually, the analysis is retrospective, right? After the fact. Like if there was a crime committed, then they'll go back and look at CCTV footage, you know, which is quite sad. Or these, I don't know if you've noticed this, these CCTV cameras that are dotted across, usually in certain places. I've discovered in certain even high density areas, we find them. I don't know if those are functioning well. They caught me one time, right? Ransom time around. I think I didn't see the speed limit, 60 kilometers per hour along Kafir Road. and I just got an SMS, and I went to this online thing. I don't know if you guys have, and they had me there, right? Well, not me, but the vehicle, the license plate. You can't argue here with the speed, is it? I don't know if you've seen this. You can look up your license plate, right? If you've RATSA offenses, or something. You can check if you committed a traffic violation, an offense or something. They actually they capture footage actually. But I don't think that it's a simple kind of tool here, but I don't think they're making better use of this, in my opinion, you know. But I had to pay, I paid using the Zamport also, which again collects massive amounts of data, right? So data is everywhere actually. Anyway, that's neither here nor there. Yes, looks like we're going to be introducing ourselves. We're great, but this is fun.
My name is Matplotlib.
Yes.
I did my bachelor's at Zikas.
Yes.
In IT.
Okay.
Yeah, and then I worked for Syllabus as a data associate.
Oh, okay.
Yeah, came out last year. And then when I worked with from this course is Python.
Yes.
Yeah, so that I think they would be predictive models.
Yeah. Yeah, you know, you guys are all going for smart care, but I know there is a bit more that goes on there. But many times it's like smart care.
The smart care DHIS to Redcap.
Yeah.
What else? OTK.
Yeah. So it's quite a bit of, yeah. I know this because one of my friend now that was my senior, I think he's still there, Vishashman. Yeah, was my senior. He was the year ahead, but he became my friend because we went to the same university. Yeah, quite a bit that goes on. In the past, actually, we invited people from Syllabus to come and give talks for data mining. I teach a data mining and warehousing course for mainstream computer science program. So it's always nice to see what industry is up like that. And then I also have, I know I started an interesting proposal. This person is supposed to use data from US for Syllabus, I think. Is it Syllabus? John Snow or something. He's trying to identify people before taking medication and stuff. But anyways, wonderful stuff. So you notice here the comments I'm giving, I'm trying to give us an idea of the broad spectrum of data, you know, telco data, CDRs, you know, data from the education sector. But it turns out that data is data, right? We've done weird things. We've done weird things here with students I work with, like the road safety project, where we are analyzing video, you know. And the way we're analyzing video data is, it's not like here, well, I mean, video data is just images, right? So what we do is, you notice here, no, ZRI, we're putting information from the database or something. CDR records from the database, right? Or raw CDRs themselves, right? I don't know what sort of format or something. But what we were, the education sector, it's like Moodle or a learning management system or something like that. But in our case, for this particular project, I worked with some brilliant students, I think. The thing about an environment like this is you mingle with smart people with all sorts of backgrounds, right? So what we did was, and again, we do low-cost research. When we don't have funding, we make sure that we spend as little money as possible. So we used footage that I capture using, I have a dash cam in my vehicle. That saved me here, you know. But what these guys did is they were interested in. So you use this. So they built a model that takes in as input, right? It takes in as input motion picture, video. And what it does is it's supposed to tell you which portions of the road have like potholes or something. Now, I mean, there's nothing fancy about that. There are frameworks that you can use, right? YOLO, for instance, which is what we used actually. And also I'm working with some master students that are extending this. But the thing here is, if you look at an analysis of this sort of data here, you begin to appreciate the fact that It's actually complex, right? Because if you remember, I don't know if you've done computing here, they would have told you, if you haven't done computing, it's okay, but I'll try and explain this. But they would have told you that motion picture, right? A video like this is made up of frames, is it? Right? Typically, when you're taking video footage with your camera or something, your camera is configured in such a way that it captures the footage at a certain frame rate. There are default values like 60 frames per second or something, right? 30 frames per second. And what that means is, like, let's say if it's 30 frames per second, 30 FPS here, what they're telling you is that in each second, in each second, there are 60 frames. Now, it's like 3 hours, 51 minutes and 30 seconds. You know, so it's 3 hours, I don't know, the math major is here, 3 hours is minutes times the seconds, right? I think, is it? I don't know. Plus, this is 51, right? This is plus 51 times 60, right? Plus 30. So it's like, in that, I don't know if we've done the right thing, maybe not, but in that video alone, what they were doing, the problem they were solving is, you extract those images, and it's expensive, right? Computational, ideally. Some of the interesting things here. So you're analyzing these. I think it should be slightly more here. I don't know. Maybe not. 260. It doesn't matter now. A second. But so it's like how many frames, right? It's this times this, right? So it's like you're analyzing just for a stretch from Lusaka to Siavonga. You're analyzing these images, this number of images, to try and detect where the pothole is or something like that. And there are fancy things that smart people have come up with, like so-called keyframe extraction, right? So there are these algorithms that people have built where you'll be able to tell which frame is more important. But anyway, I'm trying to hint at something here. The fact that there's a broad spectrum of data, that you will find yourself working, potentially working by the time you're done with this program, I suppose. Next year, in the next year, right? Apparently. We're still stage 1 or 2 or something. That's nice. Yes.
My name is Bondo. I'm computer science at CDU.
Okay.
Currently working as a full stack developer.
Where is that? Sorry?
Okay.
Okay.
What I want to get from this course is in the application of review, they generate and capture a lot of data, being able to effectively analyze and design systems that connect and utilize efficient data is something that I'm interested in.
Yeah. How far have we gone? How many companies roughly do we have registered as a group?
I'm not sure of the exact number, but it is a lot.
Yeah, it's a lot. I mean, I wonder if you do a lot of interesting analysis here. You're just interested in, they're paying the money here, right? That's fine, okay. Yes. Oh no, we are going to come circle back. Yes. Okay. Okay.
I'm currently working as a teacher.
Okay. You teach computing courses? Mathematics? Okay. Yeah, it's usually a lot easier to branch into these fields that derive from maths, right? Like if you think about the more mainstream computer science courses, most of them, you have quite a bit of math there. Even in here, actually, when you start looking at how to do it, although we are not really going to look at how exactly these estimators are implemented, if you study, you know how exactly they're implemented, you will notice in the math there for that. It's wonderful. Yes. From where? Okay. Yeah. Wonderful stuff. Yep.
Alex once said, you can probably Alex, did a bachelor's degree in library science.
From here? Yeah. Yeah, the democratic part, right? I mean, you do quite a bit of analysis there. I have a friend of mine, I guess, he works for the Ministry of Health. I think it's my friend. They do a lot of analysis of health related data in some people in some sense. Because just maybe, you know,
Not as a okay. Yes.
One. Yeah.
But I hope.
Oh yes, what do you hope to get from?
I hope to get get more skills on different things that I can do.
You know, I wanted to mention something because I'm looking at your background before I lose this train of thought, right? When we start looking at things like Python and libraries, initially, if you don't have experience with programming, it looks like it's very painful here, but the world has changed now. You know, it's vibe coding and all that, but it turns out that you'll be more effective at using some of these tools like Cursor, for instance, if you understand that internal working or programming language like Python, for instance, so that you are able to craft effective prompts that you know, that's quite. Yeah, to be maybe when we are looking at things like NumPy, what's happening here, right? But I think it would be fun. It's one of these courses where you have fun after doing it. It depends on maybe some people don't like programming and stuff. But I think you'll like it. Yeah. We'll try and see if we can include fun data sets, actually, things you can easily relate to. You know, I always like, I think maybe we can mine information from Facebook or something on social media and find if we can be interested in things, maybe. I don't know. Yes?
My name is Shalana.
Yeah.
And you can call me Jam.
Yeah.
I did my undergraduate at the University of Zambia.
Yes. In what field?
Bachelor of Science in Material Science.
Yep.
And currently investing in society.
Okay. When did you graduate?
2025.
Okay. So let's see.
So what of that like you love today and that's the whole. Just so you have like hands-on experience and the SQL.
Yes. You said what else?
Python.
Okay. Python. Yeah.
Yes. Hands-on. More practical.
You know, so it turns out that R and Python really serve the same purpose. And so if you do quite a bit of programming, you don't notice that when you learn one programming language, it becomes a lot easier for you to learn the other. So our focus is going to be on Python in this course. But you know, I must tell this story because sometimes I like telling stories. You know, I was obsessed with R. And I was obsessed, but my obsession with R, when I was doing my doctoral studies, my obsession with R was simply for one reason, right? I'm going to show you something here. I discovered that with R, I could actually create aesthetically pleasing graphs. So the whole purpose of teaching myself R, and I made sure I knew exactly how to use ours so I could generate beautiful graphs, which is quite sad, really. But if you compare, well, maybe it's not sad, but if you compare the graphs that you see here with what you can generate with the Google Sheets or, so this is my doctoral thesis, but Google Sheets or Microsoft Excel or LibreOffice Calc, for instance, you notice that it doesn't come anywhere close to some of the things you're going to see here, right? This is R, right? And I think I was using ggplot 2 or something. It's a long time ago since I used this, but I still remember. It's like riding a bicycle or something. And at the end of the day, I think when I was done, I felt very proud of myself. But I don't know if people even bother, right? Because I guess the interest is in the content. Does the content make sense? But I don't know. Sometimes maybe pretty graphs are good. In fact, you notice from the program document that for this course, the course outline that what we're supposed to look at are two key libraries that are used for plotting, right? Python libraries. We're supposed to look at Matplotlib and Seaborn. It turns out what we can do with Matplotlib is the same thing you can do with Seaborn, but one of the major selling points with Seaborn is that the output that you get from Seaborn is superior to Matplotlib. You know, I don't know. So it was it's very strange here, but when you spend a lot of time in school, I think you start valuing trivial things, right? Like you think a graph like this, a font consistent, making sure that the graphs don't even pixelate, right? You zoom in and you notice here, making sure that I'm writing it in such a way that it easily integrates with LaTeX, so that when you blow it out, it doesn't pixelate or something. But I have seen the light now, and I don't worry so much about these things when I'm graphing. It's just what's important is just the visualization does convey the message, I guess. I don't know. You know, so but when we start looking at this, by the way, these graphs, you notice that Matplotlib and Seaborn, you can actually already see the examples. If you go to the examples, you can pretty much already see that Seaborn. You can actually see that the example visualization, the galleries here, will actually signal the fact that Seaborn is, just look at this beautiful graphs, right? Compare this with these, right? I don't know. Maybe not really pretty pictures. And sometimes, I guess, when you're sending a report to the manager or the CEO, they'll just want simple things, just a bar plot, please, or something. A horizontal bar plot, but they wouldn't really want anything sophisticated, but there's quite a bit that you can do, right? Anyway, that's neither here nor there, I suppose. Yes. Okay. Okay. Wonderful.
Yeah, so what I hope to get from this programming course, in insurance, there's the massive of data. For example, the other year, everyone discussed the number of but the idea is that there is a lot of data. For example, if I'll just give an example, you would assume that every vehicle that is on the public road is insured. Okay? Maybe at the worst case, minimum third-party insurance. Okay.
Yeah. Also,
but you see each individual poses a different risk. However, the pricing that is in the market, the current state, isn't really tied to an individual's. So the risks that we are facing day to day are constantly changing, the climate is changing. So all these things they are impacting on pricing. So with the technicalities that we get from Python is able to handle it should be able to use a model that will be able to price adequately. And like if, for example, you charge Mercedes-Benz, you charge lot at the same price. We need to come to a proper agreement as to why. So there are those concerns. And also, if you look at the claims, insurance is for us to pro. Yes. Yeah, because it's a big market. So people know that they can easily. Yeah, so there are those gaps that I think research courses are going to help you like that.
Yeah, I mean, the insurance industry is one I find interesting because I have first-hand experience. And I must say this, I was with Advantage Insurance when I first got my thing here, and my experience was horrible. This thing saved me the kind of. So I was exiting at Sababa roundabout, coming from cheaper lane, getting into Boulevard. It's been what, two years, I think. Yeah, a little over 2 years. And this, I was coming to see from seeing my aunt. She was sick, so it was late. I was 21. This seemingly drunk person just hit into me, right? I survived, almost died. I had footage, but it's there on YouTube, but I didn't want to make it public or something. But that's what saved me because I had to prove. In fact, when I went to the police, right? I remember going there reporting the case because I needed the police report for me to claim something. And by the way, there's a funny story. The cop was attending to me. He's like, "Who gave you the footage?" And I'm trying to explain. It's in my vehicle. It's a dash cam. And sadly, the concept of the dash cam, I think she didn't understand what that was. Like she thought I got it from someone who gave them permission to give you the footage or something. But yeah, so the process of claiming was actually strict here, and I think some of the points we raised that would make sense now. We were trying to assess that we're not trying to be fraudulent or something, lie or something. But yeah, the footage was used as proof. I remember going to Advantage, but it took a while, and I just decided to shift, and I'm now with Madison. I don't know how effective they are. I know they were effective with my father, but it took a short period of time. But it really helped me. By the way, dash cams, if you drive, are not that expensive. Probably invest in one or something. Yes.
My name is Ishmael.
Yeah.
I call me Ishmael.
Yeah.
I do the Bachelor of Biological Sciences right from here, on the campus.
Okay.
Yeah, I'm currently a lecturer So, actually, I'm a cousin student on to the Master of Science in
Oh yeah, yes. Oh yeah, but we are going to. There's a part of we're going to benefit from home. So rather don't join some introductory lecture. Out of interest, right? Do you analyze what sort of data do you analyze? Do you analyze medical images? Yeah, there's a project we've been working on, and I say this because it's another way of talking about data, right? Different sort of data, even though our colleagues are from health informatics. But there's a project we've been working on for a very long time. It's Enterprise Medical Imaging in Zambia project. It's the reason why we have medical doctors. Ines is a radiologist. Dr. Ines Obizu, Dr. Peter Chuta is a resident radiologist. Where's Dr. Sumput? Dr. Sumput is not here, but Dr. Sumput is also a radiologist as well. We have the emi.org.zm website where we document some of the things we've been doing. And you know, I don't want to bore you with what it is we're doing in the Enterprise Medical Imaging Zambia project. Maybe I should talk about this at some point. But one of the things we're doing, this work package here, is we are two things actually. In here, what we've been doing is trying to see if we can build models that will help with the semi-automated interpretation of medical imaging. So if you go to the hospital and you're sick, right? Let's say something wrong with you, you're coughing or something, you're getting chest infection or something. And usually, the starting point is you go to a general practitioner. The general practitioner says, I think we need an examination for us to deduce what is wrong with you. So I tell you, if you go to UTH, go to the department of radiology, they're coming from, I don't know where they're coming from, internal medicine or something. You go there and you queue up and they'll tell you, we've given you a date to come for the exam or something. If it's a CT scan, right? Chest x-ray or an x-ray, not so much because we have the number of x-rays or something. But anyway, so the radiographer will do the examination and generate the image, right? When the image is generated, they'll tell you, go to this room, where you're going to is where the interpretation is going to happen. So they'll give those images to a radiologist, right? And then the radiologist will read the image and write a report and mention, so we notice an anomaly here. Now the problem is in Zambia, right? I don't know if you know this, but in Zambia, right, we have this statement here, as of 2019, and it's been a while here, Zambia only had 5 radiologists, right? Now I know most of you here, right? You are the few fortunate people in Zambia here. You're looking at this and it doesn't affect you because maybe you go to a private hospital. In fact, even when you go to UTH, you go to high cost, so you won't feel this, right? If you have 5 radiologists, the question you're asking yourself is then who does interpretation at Chipata General Hospital, right? Where my parents go to when they're sick, right? Or St. Francis Mission Hospital, for instance, Nyanja Mission Hospital. So some of the things we've been doing is can you automate the process, right, of interpretation of medical images? And we've published quite a bit on this, if this excites you, analysis of medical images, and it's a different sort of data, isn't it? Right? Medical images, quite interesting space. Something else we've done is we did quite a bit of analysis of these medical images, because when a medical image is generated, it turns out that it's supposed to be associated with descriptive information, metadata, rich metadata. In fact, the DICOM file here, I was going to show you the data that you'll actually find embedded there. It's like the details of the patient, the details of the referring physician, the details of the radiographer who did the examination, the details of the radiologist, right, who was supposed to do the interpretation, the next of kin. So we did an analysis of the 5,000 plus elements, DICOM elements. So the way DICOM files work, again, analyzing different sort of data, but the way DICOM files work is simple, right? So I'm just going to use an example here. Leopards UK a while back here. The way that DICOM files work is the same kind of way that photos we take using our phones work, right? So when you take a picture like this, it turns out that this picture here, right? This picture here is typically associated with a whole range of descriptive information. In fact, this is why tools like Google Photos are quite effective at telling you were along Leopard Zoo Road when you took this photo or something, because this information is the GPS coordinates or something. So if you look at these metadata elements, these are embedded within the JPEG file, right? Observe, if we were to count there's one here as well. If we were to count it'd be nice if you could also analyze this sort of data or something, I don't know. But if we were to count these, right, how many metadata elements? About 90, right? Slightly more. So the average metadata elements that are associated with, like, the picture you get using your phone, for instance, would be that much, right? In fact, I got this one of the fields here. I think I got this with either this 1+ phone or my other one, maybe the one that died or something, 1+ node. You notice that there's a field here that gives away the fact that this, I don't know if it's the one here, but gives away the fact that this was taken using a 1+ phone here, you know? Anyways, but with medical images, we were analyzing not 90 elements, but 5,000 plus elements. So I worked with student Elijah. We got some funding from Google Research, and we were able to hire, students who paid their tuition fee to work for us. So we did some really amazing analysis, and I think we can use that as a case example paper that we should probably look at and try and understand how the analysis was done. I was using Matplotlib to generate most of the visuals, actually. I believe we have a paper here. We can check to confirm. We can check to confirm that was a conference paper, and I'll check for Elijah. Not this one. This guy hasn't uploaded. Let me check the publications here. Elijah. But why would Elijah not do this? And I'm not looking at this. I'm looking at. Anyway, I'll share this paper at some point, especially when you start looking at Matplotlib, right? Then you see how these sort of things are generated. Yes, our other guest from Health Informatics, let us go introduce yourself. We'll do more introductions with, because I think I teach the health data management course or something, I think. Yeah, yes. Yep. Where is that? Oh, okay. Okay.
Informatics, but I feel I'm more aligned to data science.
Oh yeah, I think they're probably. I don't know, the health informatics probably does have some aspects of. Yeah, it turns out, I guess, as we are transitioning, if you notice, I mean, we are increasingly having more and more systems go online, especially in the health sector. You know, one of the things we're doing, by the way, in this project, the EMI Enterprise Medical Imaging in Zambia project, is we've been building systems, right? So currently, most of these public health facilities don't have systems in place like to store medical images and to store radiological, reports. So we've been building systems, but also it's just a matter of time, I guess, before we go fully online or something. At some point, I know SmartCare had made significant strides. Apparently, you could move around with a card or something, and I go to Spark and I'm sick to be able to have access to the medical record. I don't know how far we're going with that. I know Unza Clinic had actually introduced SmartCare, but I don't know to what extent they've actually hold it to be able to. But yeah, interesting stuff. Okay. Then we spent quite a bit of time here introducing ourselves. Don't worry, we have plenty of makeup classes. We have, I think, 2 or 3 makeup classes, so shall catch up, But some of the things I have included in here, right? I always use this opportunity to advertise our research group. I know you guys, the data science people, are doing the professional masters, right? So the UNZA, I don't know if you're aware, the UNZA has 3 types of advanced degrees, right? Master's degrees. So you can do what's called a professional master's, where it's coursework. So it's coursework this year, coursework next year, and then you have a capstone, right? Mini kind of dissertation or something. Or you can do what's called a master's, which is taught and dissertation, right? So the idea is you spend the first year doing the coursework, and then the remainder, I don't want to say the remaining year because sometimes it takes a long time here, but the remainder work on a research project. And I think the guys doing the health informatics are doing taught and dissertation. But the guys doing the data science, at least data science doing right now is professional masters, right? And then we have masters by research, where you start and you're just doing research, right? So no classes. And the distinction here, if you're wondering, but same masters too. It's not like masters by research, but the distinction is, I guess, the career path and all the things that you do. So if you're involved in an environment where you do a lot of research, probably a good idea that you're doing taught and dissertation or research only, right? Most of the health informatics people, most of you are professionals that are doing data science in here. But the distinction between the taught and dissertation and the research only is that the research only people will be working towards a tenant. So it's a thesis that you produce, whereas the other is dissertation, discourse together. By the way, I do encourage you. I've been bugging people with messages. I don't know if people pay attention to this, right? Unza is when you're paying money to be here. I know some of you are funded and maybe you don't care, but you're paying money to be here. And it turns out that you're supposed to have access to all of these all these are public defenses. So if you look at this, there was literally, I don't know how many of you bothered to, probably nobody bothered, I guess. Maybe not. But I don't know how many of you bothered to to attend this presentation. It's a master's presentation. I mean, so if you're doing a total dissertation, might as well attend, because very, very soon it will be you doing this. And then day after tomorrow we have a PhD candidate, a great Zimbabwe. I don't know if there's anything interesting in terms of data science here, but disease focus, I don't know what that is here, but maybe not. Disease focus in using efficient intelligence for epidemic prediction. Yeah. So I've been sending this message. I hope even if you don't attend the entire session, just join for a few minutes and see what the presentation is all about. You might just be interested. In fact, you might discover that there's an interesting technique that you can apply. In fact, for me, this is how I picked up on a number of things. Right, I sit in a number of the times when I walk all the way to vet and see what's happening there. Education. This is how you also find problems, I guess. I don't know, but that's neither here nor there. So, so in our research group, it's an informal grouping, comprises of members of staff and mostly students, so research students. Occasionally, we get lucky and we get funding. We've gotten funding from institutes like Data Science Africa, right? To do with what we're doing, I guess. By the way, this is me, Data Science, telling you that. I think they've advertised. They normally fund masters and PhD students. If you want to go and attend data science, they usually have a workshop, and it's a summer school and a workshop. So if you apply, they'll find you have had students. I think 2 students so far get funding to go and attend. Elijah, I know, was attending DSA 2025 last year. He went to, I don't know, some place in Nigeria there, and then it was in Nigeria, and then I attended DSA 2024 together with my master's students in Malaysia, in Nyeri, Kenya. I don't know where it's going this time around, but they normally, they've advertised, I think. They'll advertise, apply for funding to go and attend summer school, so that you pick up skills that probably won't be taught to you perhaps or something. Or just go and learn about the state of the art actually, because when we're teaching here, we'll probably just gloss over the things that people are looking at right now, the state of the art. Right? But when we attend conferences like those, it's usually a good thing here, but I don't know if I'll be able to find anything to do with. But we've gotten funding from Data Science Africa, can't find the thing here, but Google Research, recently we got funding from, most recent funding, which elapsed late last year, we got from IFU, Wakren, and Agile. Details of the project can be found here. The thing about some of these grants, they give you a little money and you can hire people to do work and all that. So we're working with these students together with colleagues like Samumba from VET, with Christine Kanyengo from the library, and with Stumbo from the library as well. And the type of data we are analyzing, the reason I'm saying this is probably throw in this as a case example as well, is we're looking at scholarly data. It's probably going to be boring for you, but the idea is the same, right? So we're analyzing information that we typically find. UNZA has like 15 journals, right? We find in our journals that UNZA listed them. And so what we're doing is, with students we're working on here, is we were crawling through here to pick data about the different issues, right? Volumes and issues of from the various journals that we have. And the reason we're doing this is UNZA aspires to be more visible online. So when people are searching for content, the things that we publish about here can be accessible to the wider public or something. So we're analyzing this sort of information, and really interesting things like working with the IPMH protocol, for instance, harvesting this sort of information here. Probably boring stuff, but I think it would be nice to use this sort of data system. We're actually also harvesting data from OpenRx as well. I think a classic example here of how you go about analyzing, I guess, this sort of data. But I'll use these things as examples, I guess. I'll throw it in here because, who else is going to read the research we do other than because when we tell you that it's part of the assignment or something, you'll be forced to read what we've published, right? Which is, I don't know if you get the joke here, but that's okay. So, we focus mostly in our research group, focus mostly on these areas. You notice one of the things is tied to this course, right? Data mining, we do a lot of data mining, and we actually mostly focus on techniques that emphasize the use of AI and machine learning techniques, right? Analyzing data. And you notice that there's broad applications, right? These other fields you may not necessarily be interested in, but it turns out that they tend to complement some of the things that we're doing here, right? So the road safety project I told you about, by the way, you can read more. If you go here, you will find publications we've done. You will find capstone project reports that students have done. You will find details of what some of my other current students are doing. Like I'm currently working with Shomo, who's a master's student, and Henry, who's also a master's student, trying to extend what these guys did. We tried before the rise of LLMs to start looking into trying to make legal and legislative documents more open and accessible. So I had a group of students actually build extractive and abstractive summarization models. Right? So the idea there was simple. If you look at current legislation, right, they'll tell you there's a statutory instrument that has been signed by the president, and it says if you are crossing the road with your headset on, you'll be arrested or something. That's an offense. And it's like, how many people understand that document, right? These guys did a study, but before doing the actual data analysis and stuff, they did a study, a baseline study, to try and understand to what extent people are able to infer what is in this document, right? There are challenges, they are long, and also they have technical terms that are used in there. And so what they did was they built models that are able to summarize that information so that the layperson on the streets will be able to understand it. Now, I'm saying we tried this before the rise of LLMs, because now, if you know how to use even a local LLM, actually, you can literally just, well, it doesn't have to be local. You can use ChatGPT or Gemini or DeepSeek, right? Summarize that. So it's become also generous, that's what I'm saying. But we attempted to do this. I don't know to what extent we can extend this here. But maybe when you learn how to use Python and all these things, you can go to the lawyers and say, if you're a law firm, I can help you build this system that will make it a lot easier for you to gain access to these legal documents. Judgments that you will find on, not just, forget about the acts here, right? That you find on payment.org, but Zambia Law. It's called judgments that you find on entities like Zambia Law or something, right? You will find judgments here, I think, here. So you can build some nice system, extract data, something like that. I don't know. Anyways, so we've done this here, quite a bit of education data mining. I gave an example of this inference model that we built that is able to, and I used it when I was teaching that course. I don't teach it, I haven't taught it in the last year or two. But when I was teaching that course, I would actually use the tool we built, right, to see the struggling students. And when you're building these inference models, it's not like they may not be the solution, right? But they will help you get to the solution. Like in our case, you identify to say, this group of students are going to struggle and they're more likely to fail. What do you do? Well, you tell the tutor to focus more on Gen or something. If that makes sense. We do a lot of obscure things here. I don't know if ZRA has a Wikipedia page, or Zamtel. It may be there, but it's probably a stub or something. So I've been working with students to try and see how best we can increase content contribution on Wikipedia. And we're harvesting, collecting a lot of data. Like for instance, literally, today I was teaching a research methods course and I was using this as an example. We did some interesting, a lot of visualizations here, type what we're going to be doing. We did this study, quantitative analysis on the Wikipedia contributions. So we're assessing awareness, willingness, and impact of gamified leaderboards. And maybe some highlights here in terms of visuals, right? Some of the things we're going to be doing, right? Things like this. So what these bar plots are showing you is the contributions by countries. And you notice that for some pages, I don't know if you can see here, but for some pages, this is the history of Zambia page. It's like the vast majority of people that are doing the edits or that did the edits of the history of Zambia page We're from the USA, followed by United Kingdom, Canada, and then Zambia. It's like, how? Somebody else is writing your history. But that's okay. What I was showcasing here is graphing, is it? Trying to understand that sort of information. There's more, I think. I hope, I don't know, more graphs in here. So Matplotlib at work or something like that. But so we've been doing this. We have sub-projects, and then this we've been working for a very long time. One of the major outcomes of this, and we're in talks with higher education authorities, we're trying to set up a portal that is going to make it possible to pull or to harvest metadata coming in from Copperbelt University, UNZA, UNILAS, right? All the universities in Zambia in a single location. So we are harvesting that data. Electronic thesis and dissertations are here. And then I talked about the enterprise medical imaging in Zambia project, which is this shown here, but we've collaborated with Investigation Hospitals and University of Cape Town. My dear friend Zola Mafaza is not here, city or something. All right, so listen, the thing here, right, is there's a case last year, and I must say this. It's a very sad case, but it's okay. It's really good student, right? They registered for 7 courses, and according to them, because the system let them register for 7 courses, so they registered like that. Ideally, they were not supposed to proceed to part 2. They're doing the taught and dissertation, but they have to do that course this year, and they've started their research. What I'm trying to say is the course itself is part of program itself, and what the program requires. In fact, what our master's program requires is that before you can be conferred with that master's, you must have a total of 240 credit units. Okay? And the way credit units are is most of our courses in the department are half courses. So they run within a single semester, a single term. They are worth 15 credit units. Okay? If they're worth 15 credit units, then I'm sure you've started doing the math here with our math majors here, right? If each course is 15 credit units, you now understand, oh, that's why Lighton was saying 8 courses a year, right? So that if you're doing 8 this year and 8 next year, you have a total of this times 2 is 240 or something. If you're doing your taught and dissertation masters, what you notice is that the research course, which is CSC 6000, is worth 120 credit units. So this year, the coursework you're doing is going to enable you obtain a total of 120 credit units, and then the other 120 you get them from the research part or something. Right? So how does this make sense here? So this is 15 credit units, the course itself, right? In your case, though, you'll notice that you may not have noticed, but in second year, that capstone is worth more. Right? The capstone project that you do is the equivalent of, now they say we're getting dumber and dumber because we use AI tools now. I don't know if you do this, it's like, what is the change? I'm ashamed. When I was in Bika, that person gave me 20 quarterless, right? Change. I think I'm becoming dumb as well. I was going to say, how many equivalent half courses is this, right? but anyway, that's 4. And so the capstone project in the case is worth more. But you notice here, the capstone is like half of the CSC 6000, those doing the taught and dissertation. Right? So anyway, just make sure that you enroll into a total of 8 courses this year. Otherwise, I won't let you graduate to do those things. And then next year, you make sure that you accumulate the remaining credit units. Right? Now, there's more. I'll provide you with detailed this course outline or something to show you this course idea is to extract some of this information from there. But it turns out, right, that if you read, this is verbatim, if you read the program document itself, it's mentioned that this course, right, programming for data science, will provide you with an in-depth introduction to programming skills essential to data science. It's like the best programming language. And I've forgotten some of the courses that you're doing, especially in Gen 2 maybe next year, but you notice that they assume that you've actually acquired the skill of programming in Python, right? Literally almost all the courses we use in Python. The only difference is the type of libraries that you'll be working with. I'm not sure if there's a natural language processing course in this program. If there is, you'll find that they'll be introducing you to weird things here like JSON, right? Or space or something like that. But that's okay. And apparently, you will learn how to write efficient code for data manipulation, analysis, and visualization. The key thing here is you notice as I start walking you through some of the libraries, in fact, I hear that for the most part, data manipulation, Python Pandas, analysis, some Python Pandas, and then visualization in this particular case would be Matplotlib and Seaborn, right? Okay? So one of the most popular programming languages in the field. In fact, I don't know if I have that screenshot here. If you follow through with, please, you find time, I guess, I don't know. If you follow through with Stack Overflow developer survey or something, developer survey. I haven't looked at last year's results yet. What they do is, one of the things they do is annually, they'll get to assess some of the most popular technologies. You know, this thing, they normally do these things differently here, but I don't know if we can have survey results or something. You know, I'm interested in data science centric things. If you see it, let me know here. Maybe we can do a search here. But one of the things they do is they look at the sort of technologies that people use, and usually use this as a way to motivate for why we're using Python. Okay, this is different here. This is generically, I mean, there's a lot of web applications being built, right? But if there's something to do with data science here, it would be Python. If there's something to do with data science, maybe I'm trying to see if I can find. I normally have a program document. We will be using NumPy, right? Pandas, Matplotlib, scikit-learn, and we'll be focusing on how we get to apply them to real-world data science problems. And apparently, by the end of the course, you have a solid foundation in programming concepts and be able to implement various data science techniques for programmatic. So what we do actually, it's probably going to be a bit boring for those of you that have some programming experience or programming experience, because we're going to take some baby steps. Introduce people that don't know how to write programs, how exactly write programs. And you notice it's actually very easy with Python. In terms of this specific learning outcomes here, right? By the time it gets to April, I think last day of class is April 17th, right? By the time we get there, you should be able to, or you will be able to write Python programs that will enable you to solve data science problems, right? And you notice that these Python programs actually involve using quite a number of libraries, right? You'll be able to use essential Python libraries for data manipulation, analysis, and visualization. Another was saying Python Pandas, Matplotlib, or Seaborn or something. And maybe for manipulation as well, NumPy as well can be thrown in there. In fact, for analysis, we can also throw in scikit-learn, because we use scikit-learn to build these inference models, for instance. But also, you will be able to perform data wrangling, cleaning, and preprocessing efficiently. So it turns out that before you can do anything, any sort of analysis with the data, one of the very first things you do is you've got to clean the data. You know, I don't know if we were supposed to discuss that. I think maybe not. But you do things like duplication, right? So if you have duplicates, you remove duplicates. Handling null values. It's quite common for certain types of data sets. If you're working with textual content, let's say you're harvesting social media data, you want to normalize information, so case folding and all those things, or stemming, is it? Depending on sort of analysis you're performing. So we shall see exactly how we use these things. It's not as hard as it sounds actually. I think when you're getting started, sometimes you go, what is stemming? If you've done a languages course, stemming, Zambia and Zambia, in Zambians, like can reduce them to the same stem, same root word or something. But anyways, so we'll do that. And then we shall learn exactly how to implement basic machine learning algorithms using Python apparently. So it appears we'll probably see how exactly we can build regression models, classification models as well. I think the key is basic machine learning algorithms. The beauty
Is there a reason why you say your dictionary the word basic?
Yes, because it's an introduction to programming. In fact, if you look at the other courses, you're doing, there's some courses you're going to be doing. I don't know if it's next term or the other term where you get to do the more complex things. Yeah. So, I mean, the long and short of it is we are doing this to teach us how to program. That's it. You know. Anyways, that's that. And then you learn how to create apparently clear and informative data visualization. So we see how we can make extensive use of Matplotlib and Python here. It's like punishment here. You see now, it's 3 hours, right? Apparently. You know what I've done is in the past is that for some other postgraduate programs, I've tried to spice things up where, because you can take a toll in that 3 hours of sitting there, and you'll do a few things. There'll be practical sessions we shall have, and when that time comes, actually, we shall tell you to come with laptops, we shall come with laptops, and we shall use one of the labs or something. But we've tried, because I've noticed from experience, I mean, I can stand here. I've been doing this for, this is year number 9, but also when I was a graduate student, I used to teach, right? It was expected if you're a doctoral student. So I'm used to standing even 4 hours, just talking and talking. And sometimes I guess you feel important, you're talking, you think you're talking sense, but maybe you're not. But we try to make it less boring, and where possible, we have some practical sessions and all those things. Yeah, it's difficult to know when you're standing in front. Am I making sense? So, I don't know. But also, we'll be able to work with real world data sets and prepare them for analysis. You know, if you look at the program document, there's supposed to be a project component for this course, right? So we shall be there. We shall probably somewhere around March there we shall start working on this project, mini project for the course itself. So I always try to make it interesting. We look at how best we can solve real-world problems in Zambia. Small projects, but things that make sense. Right? In the past, we've played around with Wikipedia. We've harvested content on certain Facebook pages. You know. Yeah. I don't know if people have wondered. Do you wonder how many of these Facebook pages being bothered to? Even in Zambia, we have a Facebook page. Do they? Customer service, do you think they even check the comments or something? It's like wounds are here. You find people complaining. No, I sent a message on social media, but they never responded. That's right, thousands of messages, right? And customer service, unfortunately, but they're planning to build apparently boards or CICT here. There's a roadmap of things actually. We even have an AI policy now and the implementation plan. How to integrate them, crazy machine learning things. But anyways, so these are the key outcomes for this course, right? Now, just remind us that this is a half course. So we are writing the exam. We are stopping towards the end of April. Afterwards, we have a short break where we prepare for the exam. And then at some point, we shall write the exam, final exam. Right? And then we're done with the course, on to the next course or something. So half course. And apparently, if you read the right? They specify how many hours you're entitled to in terms of the lecture, right? Self-study and all these things, and then ultimately those things will translate to the 15 credit units per year. Anyways, so we'll have one lecture, and I actually included things that are associated with some other postgraduate course I teach. I don't know if we're going to have paper writing sessions. It may not be necessary for this programming-centric course, but yeah, just giving us an idea of what to expect. But I think this, if you don't have the session dates, I don't know how many of you have access to the session dates here, right? We are stopping here. And the exam here, the exam is ending year exam is going to be in the week of 20th to 24th. So we're starting the exam literally here, right? 24th. So in the week of the 19th is a study break. So week of the 26th is when we start the exam or something. So probably busy with exams until somewhere around May, right? Before we come back as well. I do encourage you, please, if you haven't, I think this has been shared also, but I do encourage you to, I don't know where that is here, but I normally have session dates somewhere here. I do encourage you to have access to this, right? So exam period is here somewhere. Here. So we'll be writing exams between the 27th and the 27th of April and the 11th of May. In part because usually there are some schools that prefer full courses, certain schools, right? So they really have half courses. I think it's a lot of work or something, right? Working and stuff, but also. So which is why the examination period is too short. And then it's a short break, and then we're going to reconvene. I'm not sure if I'm teaching you next year, maybe I am, I don't know. But we're going to reconvene again beginning 26th of May, ideally. So it's usually a very short break. Okay? Hope this is making sense. Yes, I don't know. Yeah, so just giving us an idea of how we're going to cover this. My approach is usually the same. Basic introduction to key concepts, theory if applicable, and then if this, especially when we start looking at circuit training, we talk about a little bit of math behind this estimator or something, and then some protocol walkthrough or something. These are subject to change, how exactly the sort of assessment categories we're going to take into account here. So I'll skim through them. I don't think it's necessary for the programming course to start organizing seminars. So what is tagged as a seminar in the program document is actually you maybe giving a presentation of the project or working on something when we start working on the mini projects, ideally. But just a reminder here that we'll be meeting on Monday. I included everything else from the calendar anyway, but we'll be meeting on Mondays from 17 to 20. But please, I don't know if the course rep here. I wanted to already suggest Saturday session to make up for last week. I was going to suggest Sunday, but if I suggest Sunday, it will be Sunday, and then Monday we're meeting again. And by then we'll have started doing this. So I want to suggest maybe Saturday. I'm happy with the evenings, actually. If some of you work on Saturdays, I used to do a lot of. I used to like overtime at Airtel, right? If you want overtime, come and work on Saturday here. Allowances. So I know that people from the telecom sector here. So you must tell me. It would be nice if you could tell me before Friday so that I can plan as well. I do have other courses I teach, so I'll be organizing wake-up sessions. But I'm suggesting Saturday, we can do maybe 15 to 17, somewhere there. Or we can do the usual 17 to 20 if you want. I'll be broadcasting from home myself. So I don't know. You must tell me so that I plan ahead or something like that. And in the event that there's a clash or something, we'll fix the issue. But as far as I'm concerned, I don't think we have any clashes related to this particular course, I guess. Can I borrow this thing? This thing is dying here. This issue of data science, I must tell this story. I just remember. I met these people there's an event I was attending in 2019. These engineers, the mechanical engineers were attending a session. I'm asking them, what are you doing here? Why are you here? And then they explained to me, we are building models, so Afrikaners, we're building models that are going to tell us whether a piece of equipment used by mechanical engineers is likely to fail. And my immediate question is, but what what data are you using? Vibrations, you know. And it clicked there. I just remembered here. I don't know how. I thought I would tell that story here. But anyways, so it's a course structure really, the courses, and then apparently, you know, when you have very well people tell you what to do, you jump. But I don't think you jump in this sort of environment, academic freedom. But they've taught us something. You must administer the courses using the LMS. This is the DVC Academic Affairs Kusamanga, right? So this is me telling you that very, very soon, especially assessments, apparently we're supposed to be using the learning management system. We shall make sure that everybody is online before we actually fully transition to this. Meantime, what I shall start doing is I will be sharing, like this slide deck, I shall share it, today I shall email it. I'll send the direct link to a file on Google Drive or something. Okay, but we'll be using the Moodle to manage the course. Where some files cannot fit on the course, we obviously provide direct links to courses. There's always, but what about the books here? Apparently, I thought this was strange, I must say this. Some weird books that are prescribed and recommended. So these are prescribed and recommended books from the program document. I shall share the thing itself, you see for yourselves. So I'm just putting them there. But you know, in 2026, right? What you notice is that there's certain areas where you have massive amounts of information online. A lot, right? And so what you will find me doing is at the end of each presentation slide deck like this, it's like 30, at the end, you will find that I'll have a bibliography of all the resources, the sources of information that I would have used. So that if you're trying to retrace my steps or something, you have access to those things. But apparently, because people thought long and hard about these books, so I would like to some, not some, almost all of them actually have not read these books myself, right? This is not coming from me, this is coming from the program document. But it should be good books, I guess, I don't know. It's a nice way of checking some of these things. You can copy paste them. If you notice that some people are citing them or something like that, I guess you could say, maybe this is a nice book, I don't know about this. You can check this. How many people have cited this thing here? I don't know. So if it's being, although people rarely cite books, but if it's, there are some citations or something, it's decent, right? 1,000, see this, 1,301 citations. So there should be something good about it, I guess. But anyway, also, it's smart people that came up with that program document, so they knew what they were doing. So there's this. Now, in here, I'm not stating which one is a prescribed and which one is recommended. Texts have combined everything. So the first couple of books here are prescribed. They've prescribed BP medication. So they're recommending that you exercise. There's a difference apparently, right? I don't know. But so there's this Python Data Science Handbook, Essential Tools for Working with Data. I don't know why he has an iguana here, but this is very strange. In fact, all of them, right? This is a mobile or a square. But there's also Python for data analysis, right? Data wrangling using Pandas, NumPy, and Jupyter, right? So in essence, you notice here, I don't want the focus here. Probably the focus here is on Python, but the focus here is on specific Python libraries, right? So in here, you will find details of how to work with Python Pandas, NumPy, numeric Python, and Jupyter for, I don't know if you use Jupyter notebooks or Google Colab or something. Even though it's not in the syllabus, I think I shall show us how to use this because I mostly share the code I use in class. But also it's a nice way of easily creating something, right? That you can share with somebody and they see. You can even share a notebook to your boss or a link to Google Colab. Here is the analysis or fraud detection or some crazy things like that. Oh, so this is where Jupyter notebooks come in here. So the idea behind Jupyter notebooks is simple already. Google Colab is just a cloud-based version of Jupyter Notebook. Jupyter Notebook can install locally. We shall showcase to you how you install it locally. But literally, with Notebook, you don't even have to install an IDE. You can start programming right here. Okay? So you can start programming right within here. So you don't need an interpreter. You know how, maybe you don't, but Python is an interpreted language, it's not compiled. Whereas the likes of things like C++ and C are compiled languages, so you need a compiler. In fact, the end result they'll tell you is an executable file, .exe that somebody will double click and install, right? Whereas with Python, the translator needs to be there for you to execute the program, because what it does is it does it on the fly, right? Line by line or something like that. So in other words, when you're building, when you're writing computer programs using Python or Perl or PHP, you must think. It's a easiest way of getting started. Literally, you can start writing programs within Colab. So you go collab.research.google.com or something. But why is this not working here? I don't know. Okay, we're graduating. We're graduating +2 +1, right? So 2029. But time flies also. You know, when I was in graduate school here, I couldn't believe it. Like 4 years plus 2 years, master, 6 years passed by. Like I don't know before you knew it. Nothing. And then now this is, you see now, when you were saying looking forward, I don't know why they included this, right? They said this book, I don't know if it's a recommendation, R for data science, right? So the R is like a programming language. There are a lot of programming languages, right? Hundreds or thousands of programming languages, right? And I don't know all of them. Java, you know, I was introduced to programming in Java, right? The very first language, programming language. JavaScript, Perl, PHP, Python, R is a programming language. There are a lot of them also. C++, C, right? Weird things here. Weird things. Then you have people that say, oh no, for us to create Android application, we must use Go or something. Oh, wait. You know, so, so I don't know if this is going to be useful because we are primarily using Python actually, right? But I put it here now. I don't know these people, but I think it's Orali, right? Orali have a way of putting animals. These are, I don't know if this is Orali, right? And what it means. These are all Orali books. Yeah. So there's Learn Python. I don't know about this. I will share, we will start looking at the basics of Python. They're actually interactive platforms that I think will actually enable you to learn Code Academy, for instance. So we won't share this. But if you want a classic book, the review of money you want to buy, some people like flipping the pages, right? I don't know. I don't anymore myself. I don't know, but we're different like that. Some people apparently like buying a book and then like that. And then we're supposed to look at SQL, and I believe we're just going to look at it should be the specific data manipulation language. Right? So in SQL we have DMLs and EDLs, right? DML statements and EDL statements. But I believe what they say in here is we focus on the select statement, I believe. We're not going to look at the set statements and the update and the deletes. But certainly be looking at joins and all those things. You know, we used to do a lot of those. We had tables that said, select this from that, left join, and then you run. Crazy things, and then the results come and we export. We used to use Toad. I don't know if Toad is still there. You know, some of these things, I remember them, it's been a while here. Toad for Oracle. Toad, Oracle. I don't know if, was I doing Toad? Yeah. This was Toad. IDE. But those were many years ago. So there's this book, because there's a small segment on SQL. I don't know why SQL. But it's quite powerful still, right? Those of us that were telling us Oracle, SQL Server, those are relational database management systems, and you know that you interact with them using structured query language, SQL, right? I guess, I don't know. So it's still powerful actually because although there's this shift to NoSQL databases, MongoDB and all those things, but ultimately a number of these enterprise-grade applications are actually powered by relational database management systems. In fact, I'll be the first one to tell you that
I don't know if we can call these enterprise grade applications, but UNZA website, MySQL, because this is Drupal, right? What else? SIS. Our developers are specialized in PHP. It's a PHP application powered by MySQL in the backend. All these are relational database management systems. What else? Our academic promotions tool. Academic promotions tool. It's a PHP application powered by MySQL. Sometimes when you log in, you can even see an error. Developers forgot. When you log in on the session, you can see an error, SQL error somewhere on top there, right? Or something like that. Performance management tool, PMS.unza.zm, PHP application. These are all database-driven applications, but what I'm trying to say is RIPDMSs are all over, actually. Think about it. Or whenever people tell you, no, we have Microsoft SQL Server, right? That's the relational database management system. Or Oracle, classic relational database management system. But that's okay also. But also, right, SQL is so powerful, and people don't realize this when you know that you can. How many of us have used Google Sheets? I work in the cloud a lot myself. You know that you've run SQL queries in Google Sheets. I work there often myself. When I'm analyzing things to do with work, I'll just go to. Okay, I'll show you after this in thing, I guess. But you can run. You can actually literally run queries, is it? So it's quite powerful, this thing, right? Very powerful, actually. I like it a lot myself. You can use this, right? And this thing allows you to run. So this parameter here, the query, is actually a SQL query. So you're like running the SQL query on this spreadsheet. So I don't know if probably Excel has evolved to do that as well, but I don't know also. Okay, so there's this book, and then now you see when we're saying, well, we're going to be using Python and all those things, like how, right? I always let it known to say if you want to reproduce some of the things I'm using, although with Python, I think we'll try and see if we can work with something that is environment agnostic. But I normally use a specific type of environment. I'm currently running operating systems Ubuntu 24.04. Of course, I'm going to be running Python 3. I'm experimenting with something here. I'm experimenting with 7. I'm experimenting with this. What happened here? I don't know. The power is going to. No, it's the power source. I don't know what happened. But I can hear some noises here. Someone, the noise quite down here. I think they drive the power. But I was about to showcase. Now sometimes I like following things to the dot here. So we are waiting until 2030 before you shoot. I'm just joking. I want to suggest power is going here, but we can continue this. I hope you're okay with Saturday. If you want, we can do Sunday. But the problem with Sunday is Monday when we're meeting, okay? Okay, and also if you don't have the session on Friday, I don't know if you guys have, you do though. We can do Friday if you want, and choose. So I was about to showcase, I do apologize for this, power is going. But I was about to showcase the tools and services. I'll talk about the last remaining bit was tools and services. Might as well, I can repeat this again when we meet. Might as well use this opportunity here until we get to 2030 or something. But I'm joking. But I was listing NumPy, Matplotlib, Seaborn, scikit-learn, the packages that are included in the program document itself. And I'll share these slides. So what comes next are just, slides that showcase the URLs where you can get more information about local people. The reason why I provide this information to you, and I'll share the slide with by the way, is you don't have to wait until we've started looking at some of these things. Let's poke around and familiarize yourself with some of these already before you start. I guess something else that's important is I had a cost grading thing. most of our master's programs are 60-40 split. So 60% is the continuous assessment, 20% is the exam. And you know what that means? You can pass, right? Because the pass mark at the end of postgraduate courses is 50%. Apparently, it's different from undergraduate, right? And then I have a breakdown of the continuous assessment category here, you know, and then also I share something like this in the postgraduate guidelines, a very important document. I provided a direct link to the guidelines. It's just probably a little over 100, if not less than 100 pages. It outlines what you should expect at the end of before you are awarded that master's degree. And in there, they will tell you the different score ranges for the grade, right? There's A plus, 86 to 100, A, B plus, B, C plus, C is 50 to 54. And then what follows is a fail. So nothing like a B plus, like current. Quite strange. It's okay. Yeah, then I have details of my contact details. So my email address. I stay in, you'll find me in room 5 in the computer and informatics department. Also is there next Friday class, project meetings. There are times when I may not be around. What I normally do with the students, in fact, students, I'll provide my office hours where I guarantee that you will find me unless I'm sick or something, like an emergency. But in the event that you find my office hours in here, but in the event that I'm not there, with my email address, and you can just shoot me an email. I even provide a link to my calendar where you find free slots and you say, I see you have a free slot here, can I come and see you here or something? And then you can come and see you or something. And then more important, the communication, for me, all my rooms are a lot of policies, right? There's a communications policy where communication is emails. I don't know, there's this proliferation of WhatsApp. WhatsApp groups are everywhere now. And you know, it's hard for me to keep up, especially the threads in there. It's hard to keep up. What was happening, you know? And when you lose track of the conversation, that's it. You're left. So I email, right? There's a mailing list. This is where most of the information and communication actually trickle down to you. So you just send an email to dci-mac-ds@unza.ac.za. And then I have a few things about academic dishonesty. I'll talk about the guidelines, I think, when we meet on Saturday or Sunday or Friday, I guess. And then afterwards, the next session, we just have, you know, I'm just sitting here and I have like a course introduction, how to read the paper. I think we can just dive in and start the reference installation and configuration, or how to program in Python. Quite nice to create something. You know, there's something interesting about it. I don't know if those of you that have studied computers, the image that you are seeing on the one of those books here, it's not there. It doesn't exist, is it? It's not there, right? Those are just electric signals, is it? And that's a fun part about programming is you're telling this machine what to do. It's not there. It's just an abstraction. There's no image, right? Apparently, you know, it's usually quite when you're being introduced to those concepts in computer systems. It's like philosophy 101 here, confused, but yet I can see it. It's there, you know. Just like when we're discussing computer graphics, by the way, I'm waiting for questions, but I was discussing computer graphics and I was telling 4505 students that the thing about computer graphics is that there's this interesting concept in philosophy called shared perception, right? It's like what you're seeing as light on here. Are you really sure that what you're seeing is what you're seeing? But we have this shared perception, isn't it? But we don't know, right? Or we can assume that the hardware that powers us is the same, right? But it's different apparently. So maybe somebody sees something else, but we agree that this is. But okay, we are done here. We're not discussing philosophy or something. Everything is an abstraction. Apparently, we are living in a simulation, but I don't know about that. I'll see you guys soon, which is hope is Friday, Saturday or Sunday if you wish. I will wait for you to. You can let me know also who you're calling. It's always nice to have a representative, so somebody who can help you reach out to the lecturer if they haven't shown up before, if they've forgotten that there's class or something. So amongst yourselves, maybe probably Yeah, I hope this was a good enough introduction. If there are no questions, I shall see you on Friday, Saturday, or Sunday. Thank you very much. Yes. Yes, it's your feedback. Yes, it's at a technical level that the thing was positive, which is why I encourage you to start. But we're just, sometimes when we're waiting for input from a higher office, we just have to wait. But as soon as we get that feedback, everything is aligned. So it's supposed to happen.
All right.
Yeah, so that's one. We'll try and also negotiate because the issue of registration, late registration and stuff. But for these cases, yeah, we shall obviously try and see the registration. I thought you were going to say the question on Python, or no? Okay. Yes. Which one is it? I'll check and I'll get back to you. I'll have to check my program documents. They should be there. Okay? I'll check and I'll get back to you. Yeah. About electric. I think we should have a section about electric. Yes, what's the question?
What question is that? We're supposed to choose one.
Oh, so it's by the way, count is how many? 1, 2, 7.
So since there are 8, so we have to.
No, so it's a 7. So the thing here is those ending with a 1, this is the second one. Have to remove this somehow. But all this is I have to fix this.
So this is the screenshot.
Oh, okay. Okay. Yeah. So the thing is, you're supposed to choose four that have a 1, and then 4 that have a 2 or a 9 is the second thing. We'll fix this. Can you give me until for meantime, just register any 8. Is that good enough?
No.
Yeah, just register and then we'll fix this later on.
No.
Yeah, just enroll in any courses. But using the timetable, you already know I'm going to be attending classes for these courses. And then we'll formally fix this issue. Because there are a lot of people that are affected. Doing it for individuals is going to be too much work. So I'm trying to push for the system in so that we try and make it possible for you guys to correct this yourselves.
No.
Yes.
Because I was thinking that tomorrow.
Yes.
We'll be having mass quiz ethics and the.
Yes, you are.
Yeah.
Yes.
But it was not selected.
Yeah, but please attend. Yes. Yes. Dr. Miranda is coming through tomorrow. Yes, we will insist also for like I did that. Will that be enough yeah, so I'll ask the course instructors to do that. Yes.
Was this lecture online?
As in,
let's say those that did not attend.
Yeah. So I don't know. I didn't even get feedback. I just told these guys that I guess are you still there? They're gone. Yes. We were here.
I'm still here.
Oh, okay. Yeah, thanks. Were you able to get? Sorry, we didn't even introduce you, you guys, but were you able to get what we were saying?
Yes.
I'll try and see if I can bring my external microphones the next time we have class, so that you're able to do this. And then also I attempt to share because I'm recording this. I'll share this as well. Yeah.
All right. Thanks.
Yeah. We'll use your own role. Yeah. By the way, we are done with class, gentlemen and ladies. Thank you very much. We'll see you. We are supposed to have a makeup either on Friday, Saturday, or Sunday. I'm sure as a group you agree, and then I'll send a notification as well. Thank you.
All right. Thank you.
Yeah. So I always attempt to. I'll attempt to have this. Yeah. Wonderful. Okay. No. Yeah.
But there's still that issue that you mentioned.
On
recommendation.
Oh yeah, yeah. So what's your name again?